nutrition. I was like, oh, I should check in. Okay, here we go. Shoop, 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 shoop. You guys already got number 38, letter D? Number 40, letter A? Number 46. Okay, there was a lot going on in this one, yeah? Oh, I did not pull it off. Thank you, thank you. I meant to and I forgot. Like, this is thick. There's 2 pages. Okay, domain, x greater than 1. Have to set this guy greater than 0 according to our domain problem. Interval notation, got it. X-intercept, remember, set y equal to 0. Then we have to solve. And part of that solving is getting rid of a logarithm using the inverse property of 5 to the power of. Oh, that's right. We were going to add into our notes. I forgot about that. How to transform from logarithmic to exponential and backwards, just in case for some of you that might be helpful to memorize. Anyway, and then solving. The vertical asymptote is at that domain barrier, which is at 1. And then they went ahead and did a couple extra points. I don't know if you guys necessarily had to go too crazy with that. Once you have the vertical asymptote, once you have the intercept, maybe a couple points would have let you know exactly where to swoop. There it is. But some of you guys might have just taken your representative points from the original logarithm and then shifted it. How would the shifts have worked, guys? Couldn't you have just shifted the original parent function? Where'd this guy go? 1 to the right and then up 4. Good. It makes sense, though. It makes sense, though. Yeah, no, Joe's English is very good. He was just, yeah. So she was making fun of your English, but really she's impressed the majority of the time. So Joe, it's one of those you're just like, it's okay. Real quickly, what am I talking about parent function, guys? How would you get the parent function of that guy? Who is the parent function? I was going to put it on the board, but let's put it on the smart board. Log 5x. How do you get the representative key points? Because aren't those kind of important to be able to get, I don't know, do any shifting or any reflecting or any movement? There you go. You guys tracking with what Joe's trying to help us with? Remember there are 3 points to logarithms, exponentials. If you didn't know what the key points were, or the main points were, couldn't you graph y equals 5 to the x? Whoa, whoa, whoa. Why am I putting 5 to the x up here? It's the inverse of the log. What are the key points of 5 to the x? That's easier for most of our brains to figure out. What's going on at 0? When x is 0. Wait, hold on. Whoa, we're way smarter than this. Come on. I know it's Monday, but chapel was good. You had an extra long nutrition. This weekend was theoretically at least somewhat fun. If you plug in 0, anything to the 0 power is, woo, there we go, we're alive. All right, if we plug in 1, what's going on with this guy? Plug in 1. 5. 2, 3. Do you guys realize why I'm a little bit terrified right now? Yeah. Okay. How about negative 1? Okay, that's the hard one, and more of you answered than the 1. Anyway, negative 1 is 1/5, and 1/5 is going to be way down here, right? What do you do to get the logarithm graph? No, to get the logarithm graph. Oh, okay. Yes, aka switch the x and y's of each of the points. So instead of doing negative 1, 1/5, we're going to go 1/5, negative 1. Be somewhere around there. Instead of doing 0, 1, we're going to do 1, 0. And instead of doing 1, 5, we're going to do. That's how you get any parent function of any logarithmic graph, even if you're not so good at plugging into logs. You can do the exponentially guy and then switch, 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 flip, 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 the x's and y's. And then what could you do with that guy to get your final graph? Shift it 1 to the right and 4 up. Dun, 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 dun. Does that make sense? So every logarithmic graph comes from being the inverse of every exponential graph, which is why in this right here, when I said you needed to get rid of the log base 5, you can do 5 to the power of both sides, which undoes based on that inverse property we were talking about on Friday. And then you're done. Number 58 was, I think, just to plug it into your calculator, wasn't it? Yeah. Spoiled, rotten. Did you guys find the LN button okay? Hopefully, otherwise I should be even more scared. What's going on to this guy? He's an ln graph. Yes, he has an ln function that's been shifted left 5. So couldn't we have done the exact same thing, but with ease instead and not even have to do this weird, nasty decimal-y stuff? I mean, you can. That's fine. But they did ask you to find domain. Domain, remember any log greater than 0, solve. Interval notation, there it is, set equal to 0. How do I get rid of an ln? What's the base of ln? E. So e to the power of undoes. E to the power of is 1. Solve, solve, solve. There we go. Vertical asymptote. It's that boundary once again. Then you can just take that normal ln graph, which you guys had in your notes, and shift him left 5, and you're done. The vertical asymptote shifted left 5. The intercept at 1, 0 shifted left 5. You have that little, what would this be? 1 over e negative 1 that shifted left 5. And then e 2.718281 shifted left 5. Ah, you guys are warm. I'll open the door in a second. 76, what property lets you jump from step 1 to step 2? Yeah. And you could actually use both properties. You could use the 1-to-1 or the inverse. The 1-to-1 says, just drop the ln. Sweet. Oh, factoring, okay. The inverse property would say e to the both sides, and you still end at the exact same place. 78. I think you guys were just plugging in values to an equation that they gave you, right? They chose to go to a table thinking it'd be easier, going by ones. What could you do? You guys have done tables for a while now. What button gets you to the table setup to change how it's giving you data? Second. It's table setup. I think that's literally it, right? Table setup. Second window. It says table, then STP or something. Table setup. And then what would you do as your initial or your start value for this table? 5. Oh, you guys are killing me. I'm like dragging it out of you. The first value in the table is 5. So in your graphing calculator, that's where you would start. And then remember that little delta sign. What's the delta sign in that menu mean? Yeah, like the change in. And what's the change in for this one? What are we going by? Yeah, just put the function in your y1. Start at 5, go by 1s. You'll get all the values that you need. You can get a nice little zoom. They ended up going to 11 and 35. You guys know you can zoom in, zoom out, be a little bit different, but there you go. And then they were saying, hey, we can affirm the statement because there's that steady increase according to the graph. Give me 1 second, Joe. If you weren't quite sure why we started at 5, it's because of that whole, don't put in 2005, put in 5 and make it years from 2000, etc. So that's why they went from 5 to 11 was because of the time frame. Joe, go ahead. What's up? Then your answer probably would be something like if you still saw an eventual increase, you might be able to be like, well, kind of yes, but it wouldn't be able to be as solid of an answer. Does that make sense? And that's a little more true to life in that life doesn't normally give us nice little steady increases like this. It's usually more of a mess, but hopefully an overall increase. Hey, there's a life lesson in that. There was this girl a few years ago who wrote like this blog about life and calculus, put it all together. Anyway, she was basically saying that we want positive slopes of tangent lines in the sense of you guys don't know all that part. But in general, even though you might have ups and downs along the way, sometimes it's good to take a step back and be like, yeah, but am I growing? Am I increasing? Anyway, we'll come back to math. But anyway, there was a life lesson hidden in there somewhere. Let's keep going to homework questions. Oh, that would be really good. No, I think she just in general, she's a college kid and she's taking a calculus class, and so she has put a couple things together. She was doing like homework and then she was like, oh my goodness. It was kind of cool. Yeah, it was one of the Google Classroom assignments I required of Calc BC to read through a few different blogs that says, okay, calculus is all well and good, but does it mean anything for us as far as daily living? Anyway, it was cool. Guys, any evens or odds that you want to see? Was homework that straightforward? We're okay? Give me a quick head nod if you're like, yeah, I'm all right. Okay, if you're not head nodding. All right. Here we go. Section 3.3. But I did just say a second ago that I was like, oh yeah, I did want to write down, okay, let's peek back in section 3.2. Trying to find a good place to put it. I didn't want that. Back in Algebra 2. Back in Algebra 2, you guys did learn how to transform from exponential to logarithmic and from logarithmic to exponential forms. There just isn't a good place to put this. Let's go ahead and just put it at the very end of section 3.2b, okay? At the very end of section 3.2b. You guys could put it after this example. That's totally fine. I think we did that example together. Just at the very end, I'm going to put it here just because it's notes. But let me go ahead and add a quick note. And the note is how to transform. I shouldn't write in cursive, sorry. That's what I do when I'm trying to go fast. How to transform and I'm going to put a dot, 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 because we're going to say how to transform from logarithmic to exponential. I'm just going to put a little arrow. From logarithmic to exponential, and then from exponential to logarithmic. Some of you, if you just know the properties so well, you're going to master this to the point where you don't really need to memorize these formulas. But for others of you, maybe mastery isn't in the cards for you, and it would be helpful to have something to memorize. If something is an exponential form and your x, your variable, is stuck, you're going to want to somehow get it into a log form. And similarly, if something is in a log and the x is stuck, you're going to want to get it into an exponential form. So even though ultimately I would say, if you master the skills of the properties of these functions and what's allowed, what's not allowed, and the one-to-one inverse properties especially, you really don't need to memorize this, but just a few of you, it'll make you feel better if you have it written down somewhere. And we haven't reviewed it yet this year, and I do apologize for that. So what if we were to have something like log base a of x equals y, okay? We're given a log form, and if the x is stuck, and you're like, I don't know what to do, and if your brain isn't doing well with undoing a logarithm by going a to the power of, we're going to practice it more. But for some of you, it'd be really helpful to just have written somewhere. You can go to exponential form by stealing the same base, a, to the power of, I always think go back and forth, a to the go across, or maybe across and back. Go across, a to the power of y is equal to x. We've talked about how the answer to a logarithm, or the entire logarithm, is just the power of a that equals x. I've actually been saying this a lot in words. I just never wrote it for you, so I'm sorry for that. And similarly, if we were to have a to the power of y equals x, I'll leave it like that. We could make that a logarithm that says, okay, the base is a of x is equal to y. Yeah. A log with a base of x, with a base of, with a base of a, with a base from up above. Log base a will equal x when a is to the power of y. So once again, kind of been saying it in words, and there technically are these really cool properties like the inverse property now that lets us actually do math here and get here. A to the cancel out, x is equal to a to the y. Like we can actually do math now. Or log base a cancels out. Yeah, so we can use the inverse property, but there it is if you want it. How to transform from one to the other. Logarithmic to exponential, exponential to logarithmic. It works both ways. And I guess technically, my words do not match my arrows. You can go from logs to exponential. You can go back from exponential to logs. Okay, so if you want it, there it is. If you want to like star it, highlight it, that's totally fine. Some of you will find it helpful, and some of you are like, I don't really need that anymore. I've gone beyond that, and that's an awesome thing. Keep going beyond that, but there you go. All right, let's go back to section 3.3, and let's figure out why on earth I have like a blank page just chilling right after I said simplify the following. Okay, I'm going to go ahead and work out this example over here on this side. You don't need to write this twice. But here's what's a little bit crazy. Do you guys remember back in Algebra 1, what we would do if we had something like, and this is just quick review. Maybe I should put this over here so it's not in the same page as all the work. What if you had something like x to the a times x to the b? Do you remember your exponent rules? What do we do when we multiply like bases? A plus b. So if it was x squared and x cubed, I'd have x to the fifth, right? Because remember, this is repeated multiplication. That's repeated multiplication. Put them all together, and then you have a plus b x's, however many that is. So when you multiply like bases, you add the exponents. Flashback to Algebra 1 anybody? Okay. Yeah. So the same way we go from here to here, at least my foot's not broken this time. Same way we go from here to here, you can also go backwards. Why am I showing that? It's the key. Ready? We take this expression, a to the log base a of u plus log base a of v. I can go backwards because of this property from Algebra 1, and I can, oh, this is the exact same thing as a to the, yeah, just ignore that part. As I go retrieve my pen, does that make sense? Now, I put parentheses because it's kind of messy and gross. I could have done the raised dot. Doesn't make a difference. Still times. But is it technically in keeping with the basic Algebra 1 property that if there's addition in the exponents, I can make it multiplication of like bases? True or false? Yeah. Now, why is that cool? I couldn't simplify anything here. But I totally can here based on the inverse property. The inverse property says a to the power of log base a, or log base a of a to the power of, undoes each other, cancels everything out, and I'm left with just on this piece, I'm left with u. So all that goes away. And this piece I'm left with, that just equals that. Sweet. Now, are we going to see problems like this? Probably not. But what are we going to see, and what did this just show us? This just showed us that I could say that original expression, a to the log base a of u plus log base a of v is u times v. And here's where it's about to get a little trippy, which means if I were to take log base a of both sides, what I do to one side, I do to the other, totally legal. What happens over here? Yeah, that's gone, and all that's left is what's up here in the power. So log base a of u plus log base a of v is equal to log base a of u times v. And what is this called? It's called the product property of logarithms. That allows me to go from an expanded form of simpler individual logarithms to a condensed form of a single logarithm, depending on the problem. And for right now, we're trying to get ready for the harder puzzles that are coming at the end of the chapter. For right now, this is going to be helpful sometimes to have it split up into simpler pieces, but sometimes it's really helpful to have it condensed into only one. Because right now, I have logs in multiple places. That could be complicated, but I like if the inside's easy. Or maybe I like having the log all in one place. The product property says the sum of two logarithms with the same base can turn into a product, a single logarithm of the product. But that's not the only property. And some of you might be having flashbacks of the word expand and condense with logarithms. Product property is not the only one. There's a quotient and a power also. I'll give you a second to get them down. If you guys looked at the title of this section, isn't it just properties of logarithms? Guess what? 1, 2, 3, done. Whole section. 1, 2, 3, done. Whole section. I was a really cool math teacher. Part of your homework would be proving the other two properties, where they came from, using similar logic. Possibly having like a proof on a test. But I guess I'm not that cool. Or maybe I've been in high school too long. But anyway. Don't worry, if you ever have a college math teacher, they'll make you have fun with proving. But these three properties, it's the whole foundation, it's the whole point of section 3.3. But it's a super, these are super important skills. These are super important skills to be able to develop and use. Some of you got a little freaked out because there's a lot of equations on the board. But what do you notice about the first column and the second column? They're the exact same, except almost. Can anyone expand on what Joe just said? Hold on. That was good. One's a natural log. That's this column. What description could you guys give trying to explain what this column is showing? This is the natural log. What's this column? Don't just say the words. Not quite the words I was looking for. Kind of. You're getting closer. Come on. You're just saying the words now.
With base up there.
You're just cheating.
Not cheating on the board.
Except I said you're not allowed to say those words. What's like an easy way of explaining what's going on? Why did they write them twice? No, that's okay. That's partially it, right? Natural log is ln. That's awkward. We already talked about like the Latin or whatever it came from. Did we talk about that?
Yeah.
Yeah, I did, right? The Romance languages, romantic languages, how the adjectives come after. Oh, we did that in honors.
Yeah. Yeah, you did.
Jason remembers it. Anyway, how the adjective comes after the noun. So maybe ln, English wasn't around, at least not in the form that we have it today. Goes out to Miss Gudermuth. Anyway, history of the English language. Seniors are having fun with that this year. Anyway, adjectives go after, so ln. Anyway, it's confusing, right? Everything is log, ln. So part of it is just reminding you ln is a logarithm. He's going to behave like a logarithm because he is a logarithm. Anyway, part of it is just reminding you of that. But part of it is saying what is, bummer, I thought someone would get it. What is generally true, right, is also specifically true. So that's the general property of just any logarithm, and that's the specific one says, oh yeah, by the way, any logarithm, ln is included. So it's not so much you guys have to memorize them both. Like these are the properties right here for any logarithm, but it works for specific as well. Okay, moving on. So which one looks to actually be using one of the properties up above? Yeah, go ahead and try B first. A is a little bit more confusing. Try B first. You seem bored, so why don't you work on multiple choice? And then we'll save that one. It's 15 minutes, and that's only 4 problems. Oh, sorry, Jason. My badge hit you in the head. Yeah, YouTube, it just goes by days, so you can go back to where we started chapter 3, which was last something. When did we start? Took our test on Friday. Wednesday? We were on retreat. Oh, we took the test earlier. Was that right? Okay.
Why do you think I asked her?
So now we're good. We're all on the same page. YouTube videos. She's going to go check them out, and we're going to be better. All right. It's okay. But wait, hold on. Right now, you're just supposed to be plugging into this guy, right? Why that guy? Well, he's the only one that has division. So, what'd you guys do? Did you write 2 logarithms, both with a base of 10? 10? Yeah, remember common log? Look at the button in your calculators, 10 to the power of, and the second button. Who goes first? Log of?
9.
Good, the top guy, right? Minus log of? Oh. Why did I start to write 100? What did I see? Yeah, why not reduce the fraction and see if we can make it easier? Why not make this log of 3 over 100? Oh, okay, that was weird. I know. Why is it better to make it 3 over 100 than 9 over 300? Well, first of all, the number's smaller. And second of all, what did I just say the base of this logarithm is? Oh, and 100 is 10 squared. And logarithms answer what power?
So it's 2.
So I could rewrite this as common log of 10 squared. If you guys remember that this is a common log with a base of 10, according to the inverse property, log base 10 of 10 undoes, and all that's left is 2. And the original log 3. Now, what do you guys think about that as an answer if I was to box it? This is what the book would do. They would box it right now. Why do you think I don't like it?
You can simplify. No, you should put 2 in front or something like that.
But why? Why is Joe saying, thank you, Joe. Joe, shh. Make them think. Why should we put the 2 in front? Well, actually, that's a little bit wrong, but I think you would have done it correctly. Why should the 2 not go right here?
Yeah.
Okay, right? I mean, does it go? Does it not go? I don't know, right? It's going to be a lot better if we do negative 2 plus 3. Sorry, log of 3. Because right now, I don't know. I mean, we could put little parentheses. The book doesn't even do that. It just says, yeah, it's great. No, it's confusing. So put negative 2 minus 2 plus a negative 2. Put it in front. Now box it and be done. Wait, can't we go further on him? Log base 10. 10 to what power is 3? So yeah, we're not going further on him. We'd have to go to our calculator, get a nasty decimal. Would not be fun. Just don't go any further.
Yeah.
Does that make sense?
But if like that was our final answer and we boxed it like that.
That's probably fine. But just don't go any further. Does this apply to any property outright right now as is?
No.
Is it a multiplication? Is it a
It's 1.5.
Can I make it a multiplication? Can I make it a division? Can I make it to a power? Oh, stink. We can do any of those. We could make it 2 times 4. We could make it 2 cubed. We could make it 16 divided by 2. What do you guys want to do? 2 times 4? Sure. So if we were to make it, you might not realize why we're doing this. But if we were to make it 2 times 4, now what property applies? Not power. Product. Product property says a condensed product becomes an addition of 2 separate. Well, how did that help anything? Log base 4 of 4 to the 1. Ooh, just becomes. So pause. How am I going to go ahead and say, yay, I'm done. Dun, 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 dun. Wasn't magic, it was math. Oh, it's not even calculus. What did I do? It's actually algebra 1 if you can get there. It's just a little hard. It's a little hard. What I did. What did I do?
4 to the half power.
I saw 2 as the square. 2 is equals. 2 as the square root of 4. And I was like, oh, this is the same thing as log base 4 of 4 to the 1/2. I can do logarithms in my head. Perhaps. Not all, only the nice ones. Nice? He wasn't nice. Well, he kind of was. 2 is the square root of 4. We looked at this last week in the sense of, remember, all the logarithms will become 1/2 when the argument is the square root of the base. All right, tricky, I know. But it was right. Okay, now these were tricky because they were kind of hidden, like the actual objective of the problems. Was it just applying the property? No, it was applying the property and then being able to go further. To apply the property and then to go even further in as far as keep solving. So that was a little tricky. It wasn't super specific. So let's get to very specific directions. Here's one direction you might be given. Expand. Expand. Expand means to make bigger. Thank you, Jason. Bigger. Some of your voices, I swear, I wouldn't recognize them if I ever heard them and I couldn't be looking at the class because I never hear your voice. AKA, Joe is an excellent participator. And is very confident in math. Pause. If either of those things do not describe you, it's hard to talk in class, right? Either A, you're not very confident in math, or B, you're not a natural participator in the sense of talking out loud. That's not necessarily bad. We need the deep thinkers, the reflective, more introspective ones. But I think most of you knew that answer. To expand means to get bigger. And so I did give some specifics. To pull apart. Think of a balloon expanding or blowing it up, right? To pull apart a single logarithm into, and being very specific, into a sum and or difference of simpler logarithms. So there's a very specific direction that we're going to go with all those properties we just wrote down. We're going to always, when they say expand, be taking a single condensed logarithm and basically pulling it apart, breaking it down legally with all the properties we just showed. So I'm going to come back to the properties, and it might be a good idea if you guys have a colored pen close to label something in the properties. It's going to help you with the directions. Expand, to make it grow bigger, like when you blow up a balloon, right? Expanding, expansion. And all these properties, I would do the following with your colored pen. I would go ahead, if I were you, and I would label all the logarithms on the left side as condensed, and all the logarithms on the right side as expanded. So if it says to expand, you're going to be going from condensed to expanded. You're going to be pulling apart a single logarithm into sums or differences. So products, quotients, or raised to powers, you're going to be simplifying them or expanding, pulling them apart. And specifically what we're talking about are the arguments. So a single logarithm becomes multiple. And if you're trying to go the other direction, soon we're going to talk about the word condensing, bringing together. We're going to be going from the expanded towards the condensed, trying to bring it all into a single logarithm if possible. Okay, so that's just the vocab. So when you see this word expand, you already know, hopefully, what you're going to see. You're going to see condensed logarithms, single logarithms, but you're going to see single logarithms with some messy stuff going on inside. If I was to put a plus, and if I was to put a log base 4 on one side and a log base 4 on the other, hopefully most of you have already figured out what property I'm referring to. What property am I using? Why? Because there's multiplication. Yeah, exactly. Okay, so what do you think I could put in the first logarithm? Sure. How about the second logarithm? What would you do or think if I said, but we're not yet done? To fully expand. Split the 5? Well, can't I just like bring down the 3 and be done? No. Ooh. Why can't I just bring down the 3? It's missing parentheses, I think is what Joe's trying to say. It's missing parentheses. The x is being cubed. Is the 5?
No.
What would it need in order to be? Yeah, it would need parentheses. So the 5 is to the 1. It's just 5. Just 5. Not 125. It's just 5. 5 to the 1 and x cubed. So yeah, I need to split these guys up because they're working not against each other, but they're working separately from each other. So the 5 is his own guy times x cubed. And then times, from up above, the y. So technically, we could have gone straight to this. That's even better, but there is one more step to expansion. It's just not quite as clear. Good. Products become sums, but then also powers get brought down. So now that I've split up the 5 and the x cubed, now I can go ahead and bring that 3 in front. And now this is fully expanded form, unless there's some mental math or some simplifying we can do with the logarithms. Do I know what power of 4 5 is? It's not 4 to the 1, it's not 4 to the 2, I don't know. Okay, box it, you're done. Expanded form, done. So how about this guy? I wouldn't start there. I would start with the division. And I would do ln with the quotient property. But why am I rewriting this really strangely? Did the quotient property, top minus bottom, ln of top minus ln of bottom. But what did I do with my square root? Because what am I about to do? Powers come down in expanded form. So I need to see the square root. You need to see the square root as a 1/2 power because you are trying to make the inner arguments as simple as possible. Wait, split up. Are there any condensed ln's with subtraction? There is absolutely no way of breaking that apart. Okay? A lot of you could actually, to be honest, probably bust out this entire homework tonight, but we are going to go